Good day. This is Module 2, presenting unit vector. If v is not equal to 0, then v over magnitude of v is a unit vector in the direction of v. The equation v equals magnitude of v times v over magnitude of v expresses v as its length times its direction. A vector v of length 1 is called a unit vector. The standard unit vectors are I, whose components are equal to 1, 0, 0 in angle bracket notation, j equals 0, 1, 0 also in angle bracket notation, and k equals 0, 0, 1 in angle bracket notation. Any vector v whose components are equal to v1, v2, v3 can be written as a linear combination of the standard unit vectors as follows. V equals V1, V2, V3 is equal to V1, 0, 0 plus 0, V2, 0 plus 0, 0, V3. So in this case, we have V1 being written as its first component in the first representation as a linear combination with the second component 0, 0. Then the second vector written in its component form, we have the first and third component are both 0. Then we have V2. Then the third vector, we have the initial or the first component and the second vector as 0 components. And we have the third component, which is V3. And with that, we can have V1 factored from the first vector represented by V1, 0, 0. Then in the second vector, V2 was factored out. And lastly, in the third vector, V3 was also factored out. And leading now, or giving us rather, the components, we have V1, 0, 0. Then here we have 0, 1, 0. Then we have 0, 0, 1. So with that, we can now express the corresponding components of your vector V as a linear combination of the standard unit vector as V1I, because I has 1, 0, 0 component, plus V2J, because J has 0, 1, 0 component, and lastly, we have V3K, because the third component, 0, 0, 1, is a component of your vector K. Normalizing a vector. The process of multiplying a vector V by the reciprocal of its length to obtain a unit vector with the same direction is called normalizing vector V. In symbols, it is you have unit vector represented by U equals V over magnitude of V.